Hello and welcome back. This is the Wheatley tutorial part 3.5, using OnShape to design the personality core Wheatley from the video games portal. There was a major mistake I made during this video, which is that I started working on what would be effectively the back of the personality core rather than the front. So I didn't realise this until later, so I had to use the branch off tool to flip the shell around and then bring the parts back out of a branch off with the shell flipped the right way, and then flipped everything after that into the right direction. On reflection, it was a step I didn't actually need to take, considering the back and the front of the shell are practically the same. But yeah, just goes to show, regardless to how many times I've done this, I still make mistakes. I keep referring to the rollback tool as the branch off, but it really isn't. They're two separate functions. Yeah, as you can see, I've just flipped the shell's direction, unrolled all the parts that I rolled out, and then I go and roll them back into the right direction. And I've had to use the mirror tool, using a variety of different versions, including an intercept mirror, in order to get the components to mirror the correct way. I've decided to slow down the video here so that you can see the dimensions of the servo motor that I'll be using. The dimensions are acquired from Mr. Vault's personality core CAD model using the same servos he used, simply because it seemed more efficient to use the same as him, as they clearly have enough power to move his personality core. But I had to make sure that they would fit and be able to slide past the faceplate. So I've made modifications to the shell, which includes dropping the pulley into it, as you can see here. Unfortunately, I got rid of the original design footage for this by mistake. I'm not sure I even actually recorded it, because I can't find it anywhere. But you can get the idea of what I've done. So I've used the pulley feature to draw a belt that I've then extruded the outside of it and then made some adjustments to it, and then I'm just going to extrude it into the shell. And I've done an up to face extrusion on it. That means that it won't stick out the other side of the shell, and it should sit pretty flush. And then when I mirror it, it should mirror quite nicely onto the other side of the core. You just need to make sure to select reapply all occurrences. And then you can see the problem here is that the pulley would simply fall into the design, into the bearing stop thing. So I've reduced the size of the hole so that the motor doesn't drop in, and that the actual pulley is locked against the frame. There would be a thrust bearing underneath it to allow it to rotate constantly without rubbing against the mount that's attached to. As you can see, there's only really one hole that the bolt would fit into. So to rectify this, I've decided to make the sticky out bit, an official word there, sticky out. This bit basically enables me to connect my connect the servo motor to the frame reliably without worrying about it without worrying about the motor moving around instead of the handles. Although you may have noticed that I haven't taken into account the fact that there should be a big bearing block right underneath the servo motor. I mean, you saw me messing with it earlier, but I completely forgot about it. That's going to be rectified in the next video, where I'll just take a chunk out of it to enable the bearing to fit. Luckily, I've got a plan for fitting the bearing in, which will involve splitting the design of it into two parts. The two parts will be a top and a bottom. The main bearing goes in, then the top bit can be slotted in, rotated round, the bottom bit can then go in and it will lock the bearing in place. But it also enables us to get the clearance to actually mount the bearings. Now, you may have noticed I've just put some pulley supports in place. This because the pulley would be running the belt directly through the motor mount. Now, I could do away with the motor mount completely on this side and just have it attached by 3 bolts, but I really wanted all 4 bolts especially as where that pulley is going to be the pulley that the bolt that would experience the most tension and compression. So I've had to make this two-stage bearing. This allows the belt to go around it without interfering with the motor, and should prevent the belt from wearing out. And you merge these two parts together so that they're just one, so that the belt would actually work properly. Because of the design of the servo motors having the wires come out on the side of them rather than out at the back, I'm going to have to make 2 dummy servos and 1 real servo. As you can see, the pulley was right in the way and the belt was just going straight for it. So I've rectified that. Now I just need to make adjustments to the side walls where the pulley goes in. That's pretty easy to do. Just going to branch it off whilst I do the work on it. Roll it out, I mean. Yeah. So the reason for using 2 dummy servo motors is that 2 of them will actually just act as support, whilst 2 servo motors will actually be doing the heavy lifting. As you can see, I'm just playing around with the belt here a little, trying to get it in the right place. But the idea behind my design is to cut down on the amount of motors used without affecting the design. That's why I'm going for the pneumatic drive mechanism that will drive the Personalities Core's eye in and out on its Stewart's platform. I'll be using pneumatic pistons connected to a pump. That motor that I designed on the back of the shell that seems to do nothing will actually just be the pump motor. So I think that would work quite nicely. Pneumatics are quite quiet, so won't make too much noise. But yeah, as you can see, a lot of thought went into trying to get the pulley past the shell. So I decided that I need to trap the belt so that it wouldn't come off of the handles if a lot of load was put on them. Say someone tried to pick it up by the handles. This could lead to the belt just slipping off. Now, as you can see here, I can see that the bearing block is there. I just completely forgot about it, considering this block doesn't move once it goes in place. So I'll split that in half and now use the frame to actually lock it in place. Interestingly, with personality cores, they seem to have a data port built into the side of them. It really doesn't serve much purpose, but when I build this, I will be using a USB-C plug, and I'll use it similar to how the MacBook uses USB-C, so it's data in and out over Thunderbolt 4 type connections. I think it's Thunderbolt at least. But yeah, that should enable data input and data output, so I'll be able to program the personality core without actually having to strip it to pieces, which should be time saving. Now, with most of the cosmetic work finished, we need to start working on the handlebar assembly. I'm not really going to tell you how I drew it, I'll just show you. But the dimensions for it were purely what I thought looked right. So there's a few alterations that may have to be made. Quite a few iterations will need to be done to get it to sit just right. But here was my first attempt. It didn't work out too well. I ended up modifying it. I've decided to draw the faceplate for the personality core in a really peculiar way that actually made a lot of sense at the time, but on reflection doesn't make much sense because it doesn't give me a lot of room to work with. Behind the faceplate I'll be fitting the custom made PCB that I'll be designing using Flux AI, which is a really useful online circuit CAD platform that integrates circuit design with artificial intelligence with use of their AI chatbot system named Copilot. Now, whilst I don't really know that much about custom computers, Flux AI is able to fill the void of my knowledge and create very efficient circuits, but it still requires the user to actually design the circuit. So what you're seeing me doing here is getting ready to revolve the faceplate, but I then had to go back and edit this so that I actually had a slot cut into it for the new circuit board to fit in. Now, the reason in the previous video that I made the PCB sphere with rectangle blocks rather than triangular rectangles, I'm sure they have a particular name, but the reason for this is with Flux AI you can make triangles, squares, rectangles, circle PCB boards, but I don't know how to do custom shaped PCBs. So yeah, what I'm doing here now is setting up some planes for creating a slot in the faceplate of the personality core. These slots will be used to revolve a smaller disc inside that I can then graft the two sides of the faceplate together once I've split it, and that forms the finished faceplate. And then all that's really needed is the individual PCBs, which there will be a lot of, at least 20, just for the shell. They will all function like a customized Janssen Nano, and the eyepiece for the personality core will just be a piece of plastic that the addressable LED light strips will illuminate the colour that's required.